The next class about software effort estimation techniques mainly consist of two different estimation techniques. One is the extension of the previous one, function point analysis or Albert function point analysis. It is known as function points mark II. Function point mark II. And another one is known as object points. Object points. In this class we deal with these two effort estimation techniques, function point mark II and object point effort estimation techniques. The Mark II method was originally sponsored by Central Computer and Telecommunications Agency, CCTA, Central Computer and Telecommunications Agency. Now the Office of Government Commerce or OGC, Office of Government Commerce, also known as OGC in short, which lays down standards for United Kingdom government projects. So it is an organization lays down for UK government projects, standards for UK government projects. Here the label Mark II along with function points. It can be considered just like the second version of function points. The first was Albert's function point analysis and the next is Mark II, function points Mark II. The label denotes an improvement and replacement of the previous method, Albert method. The Mark II label implies the refinement or the improvement of the Albert function point analysis method. Several refinements are made to the Albert method, and function point analysis or function point Mark II method is developed and it remains a minority method used mainly in the United Kingdom. According to Albert, the information processing size is initially measured in unadjusted function points. Unadjusted function points, there we denoted it as UAF, unadjusted function points, to which a technical complexity adjustment can be then applied. The assumption is that an information system comprises transactions which have the basic structure. Here the model of a transaction is shown. It consists of a process. From the user, input is given to the process and output is returned to the user. While processing, data can be read from data store, and after processing it can be stored into the data store. It can be considered as a model of a transaction. Information systems comprises transactions, set of transactions. For each transaction, the UFPs are calculated. Unadjusted function point are calculated. WI into number of input data type or data element types plus WE into number of entity types plus WO into number of output data element types. The equation is, or the formula to calculate the UFP is WI into number of input data element types plus WE into number of entity types referenced plus WO into number of output data element types. Here WI, WE and WO, three different weightings are represented. WI represent the weight for input. WE means weight for entity type. Entity type means the external entity types, the 5 external factors. And WO, weight for output. Then weight for input is multiplied by input data elements. Weight for entity is multiplied by entity types. WO, weight for output, is multiplied by output data elements. And these things are added, we get the UFP for each transaction. WI, WE and W are weightings, and they are derived by asking the software developers, one who develops the system, the proportion of effort spent in previous projects or previous software developing the code dealing respectively with input, accessing and modifying stored data, and processing outputs. So the weights are derived from the developers based on the historical projects or the previous projects that they have already done. WI is derived from the inputs, WE is derived from the processes or the external entity types, and WO is derived from the outputs. Function point mark to follow the Albert method in recognizing that one system delivering the same functionality as another might be more difficult to implement because of additional technical requirements. The Albert function point method identified 14 technical complexity adjustment factors. Here mark 2 function points identify 5 more factors. Interface to other applications, special security features, direct access for third parties, user training features, and fifth one, documentation requirements. First one is the interfaces to other applications. Our application can be connected with different other applications. What are the various interfaces to other applications? Second one is apart from the security features, what additional or special security features are implemented in our application? That is the second factor. Then third factor is the direct access for third-party softwares, external softwares, third-party softwares, external vendors, how they can access our software, or from our software, how to these third-party services can be accessed. Direct access for third parties. Then fourth one is user training features. User training. What are the features to be implemented for users, for training users, how users are trained, and the fifth one is the documentation requirements. Everything, a document should be maintained for everything. So what standards, what requirements, what procedures, what policies should be followed during the documentation. So So the fifth one is documentation requirements. Additional 5 factors other than the Albert function point. Here 5 factors are: first one is interface to other applications, second is special security features, then third one direct access for third-party softwares, fourth one is the user training features, and the fifth one documentation requirements. The addition of other factors to suit local circumstances is encouraged. Here then we can see total 19 factors, 14 technical complexity adjustment factors identified by Albert, and additional 5 factors. Total 19 factors can be represented here, or it can be used here. Our next approach for software effort estimation is object points approach. Object points. This approach was developed at the Leonard N. Stern School of Business, New York University. It has similarities with the function point approach, but here the features that might be more readily identifiable are used. Here this approach uses count of screens or count of reports or count of the 3GL components that an application might possess. It is these that are referred to as objects. Instead of using function as an estimation, here in this estimation method, we are using objects. The objects are the building blocks, or the objects are the building tools, like forms for input, reports like output, and 3GL components or the user interface components, user interface screens, etc. Such type of objects are used to calculate or to obtain the estimation. So object point estimation is based on objects that an application might possess. Each object has to be classified as either simple or a medium object or a difficult object. Objects can be classified as simple, medium, and difficult. Three classifications can be done for the objects. The scheme used to classify the objects are shown in the table. Here I am using tables to show two objects. One is object point for screens and the second one is object points for reports. In the current table, that is the object points for screens, it shows how an object is classified, or how a simple object can be defined, or how a medium object can be defined, or how a difficult object can be defined. Three simple entries, three medium entries, and three difficult entries are tabulated based on the number of views contained and the number and source of data tables. Four different columns are shown in the table. First column is number of views contained. second, third and fourth represents the number and source of data tables. If the number and source of data tables is less than 4, or if it is less than 8, or if it is greater than 7, they are tabulated as second, third and fourth column respectively. From this table, we can define certain rules or decision rules. If the number of views contained is less than 3 and the total number and source of data table is less than 4, then the entry is simple. Then the entry is simple based on one more condition. Out of the total number of and source of data table is less than 4, out of that the server is less than 3 and client is less than 3. Server is less than 2 and clients are less than 3. Then that entry must be simple. Then a rule can be defined as, or we can define a if then rule. If the number of views contained is less than 3 and the total number and source of data tables is less than 4, then out of that total number, server less than 2 and client less than 3, then the entry can be, or the object can be classified as, or object can be defined as a simple object. One rule. Then next, another rule is if the number of views contained is less than 3 and the total number and source of data tables is less than 8, second column. Out of that 8 or less than 8, server must be less than 3 and client range between 3 to 5. Then it can be defined as simple. So based on the table, we can define a minimum of 9 rules, that each rule represents how a simple object can be defined, how a medium object can be defined, how a difficult object can be defined. Based on the object point for screens, we can define. Then next, the table shows the object points for reports. Similarly, that of screens, the table shows the object points for second object. There also 3 simple entries are defined, 3 medium entries are defined, and 3 difficult entries are defined. In both tables, the diagonal entries are medium, the values above diagonal entries are simple, and the values below diagonal entries are difficult. Like that, the entries are tabulated. Here also we can define a certain rules, certain if-then rules. If the number of sections contained is less than 2 and the total number and source of data tables is less than 4. Out of that 4, the server is less than 2 and client is less than 3. Then such an entry can be defined as or classified as a simple object point. Similarly, 9 different rules can be defined. Such rules are tabulated in a table. That table is tabulated here. Object points for report. The number of objects at each level are multiplied by the appropriate complexity weighting. The complexity weighting is object point complexity weightings are shown in the table. Then the weighted subtotals are then summed to get an overall score for the application. The overall score for an application is obtained by adding together the weighted subtotals. Here in this table we can see that for an object type screen, the complexity weight of simple object is 1, medium object is 2 and difficult object is 3. For the object point report, the complexity weight for simple object is 2, medium is 5 and difficult is 8. Here one more object is included in the table, 3GL component. 3GL component, no values for simple and medium objects, and the complexity weighting for the difficult is 10 there. It is shown in the table. Finally, a productivity rate has to be identified. The productivity rate here is denoted as capital PROD, productivity rate PROD. Some of the objects might not need to be developed as they are already existing components that can be utilized. The object point score can be adjusted to take this into account. The new object point score, that means the adjusted new object point score is identified based on the percentage of object points that can be reused. Then we identify the productivity rate. While calculating the productivity rate, it would be best if the estimator could use details of past projects to derive this. Here in this table, the developers of the object point have published to calculate the productivity rate. Developers' experience and capability, I-case maturity and capability. The productivity rate may be very low, low, nominal, high and very high. If the productivity rate is 13, it is considered here as nominal. The value go below 13 is low productivity and value greater than nominal. The value greater than 13 is high productivity. An estimate of the person months can be calculated from this productivity. The new object points, the adjusted new object points and the productivity rate ratio can be used to find the person months. The estimated effort for the project will be the person months needed to carry out the project, and that can be obtained by dividing the new adjusted object points to this productivity rate.